Hello everyone, I will go ahead and explain you guys exam 2 practice questions, how to answer these questions. Even though I have given you the answers, so some of you would like me to make a video for explaining the answers. So let's go ahead and do that then. So the first one, what is the product of the following reaction? So you have a bromo compound, okay, alkyl bromide. In the presence of magnesium and tetrahydrofuran, it is going to form the Grignard reagent. So the Grignard reagent is that you are adding a magnesium between alkyl group and the bromide. So the magnesium over here gonna go between these two bonds, carbon and bromine. So you're going to be making this carbon magnesium bromide. Okay, so that is how the Grignard reagent is being formed. That's it. And then what is the major product of the following reaction? So now this is organocuprate, meaning you are adding the alkyl group on the copper and then do a acidic workup to give you the hydrogen. So you know copper is a metal, electropositive, and then the carbon next to the copper will become electronegative. Okay, so that can act as a nucleophile. So when the nucleophile attacks, and this is going to attack in a SN2 fashion, so it always goes to the less hindered carbon. So this carbon will go to this carbon, because the other side is going to be a tertiary carbon which has several alkyl groups attached. It's more hindered, so then this would open up. Okay, so then you will have this molecule, oxygen will be on the other side, O minus, and from this side you have the carbon which came with the epoxide, and there are two more carbons added from the cuprate. 1, 2. Okay, so 1, 2, 3. So now we have 1, 2, 3 carbons chain. So the first carbon right here, if I number it as 1, that is that number. And then the 2 carbons coming from the cuprate over here. There are 2 carbons right there. So that is going to be your second and the third carbon. Okay, so either you can leave it as CH3 or just keep it just with the bond like that. And that is the first step. Okay, and then when in the second step, when you add acidic water, so then the oxygen O minus become OH. Alkoxide anion become OH, and then it needs to be connected. Like this. OH over here, and then 3 bonds right there. It need to be connected. Okay, like you got the idea. It's not a double bond, okay? So that is the structure with the cuprate. And then the next one, what is the product of the following reaction? Again, the same thing. So we can make a cuprate react with an alkyl halide. Okay. Here again also, the carbon next to the copper going to be electronegative. So we can directly replace bromide with the alkyl group. So this is the alkyl group. So one of these groups is going to attach to the alkene carbon. Okay, so the product is going to be carbon-carbon double bond, and you have the hydrogen on the other side. Methyl group as it is, this methyl group going to stay there, and then the bromide, alkenyl halide bromide will be replaced by the group on the copper. So there are 3 carbons long chain, so it would be 3 carbons, CH2, CH2, CH3, like that. Okay, that's the answer for that one. And then number 4, what is the following compound's common name? So the common name here is, so this is acetaldehyde. Acetaldehyde molecule is this CH3COH. So this is acetaldehyde. Okay, now here we have a chloro group. So CH2 has a chloro group and then the carbonyl group and then the hydrogen. So remember, if you can name these as alpha beta, so the carbonyl carbon is this one. The carbon next to the carbonyl carbon is the alpha group. So this is alpha. So on the alpha carbon there is a chloro group. So alpha chloroacetaldehyde. So that's going to be E is the common name. Okay. And then the next one, what is the following compound? Systematic name. Now we have to number them. First thing is we need to identify which one is going to be our functional group, main functional group. What is the main functional group we have? And in fact we have only one, which is going to be our aldehyde group. And we give number 1 to that, giving the priority, and then you're going to find out the longest carbon chain, 1, 2, 3, 4, 5 and 6. And then we're going to look at what are the substituents we have. On the third carbon we have a ethyl group, so that's going to be 3-ethyl. And on the fourth carbon we have a methyl group, so that is going to be 4-methyl. Now these two groups are going to name in alphabetical order. What comes first? MOE in the alphabet. That's going to be E, right? So because of that, it's not going to go by the numbers, but it goes by the alphabetical order. But in this case, the numbers and alphabet both comes in place, but this is going to be then 3-ethyl 4-methyl. So that's going to be our substituent. So you start with 3-ethyl, and then we have 4-methyl. So those are the substituents. Then we need to know how are we going to name the parent carbon chain. Now this is an aldehyde. How does the aldehydes end? As L, right, in the systematic name. And then we need to figure out how many carbons long. There are 6 carbons. Hex. So it's going to be hexanal. Okay. 3-ethyl 4-methyl hexanal. Hexanal. That's going to be the name for this compound. And then the next one, what is the following compound? Systematic name. Now again, this is an aldehyde. We give the priority to the carbon chain that carries our functional group. 1, 2, 3, 4, 5, 6, 7. So we choose the longest carbon chain. And then we're going to look at what are the substituents we have. So on the second position, we have 2-chloro. And then what else we have? On the 5th position, we have a methyl group, 5-methyl. Those are the 2 substituents. And the 7 carbons long, it is heptane chain, but since we have aldehyde, it should end in heptanal. You don't have to say 1 heptanal because aldehyde always a terminal carbonyl group. Should be in the number 1 place. Okay, so between C and M, C takes a priority lower in the alphabetical order. So then your name going to be 2-chloro 5-methyl heptanal. Okay, 2-chloro 5-methyl heptanal is the systematic name. Heptanal. And then the next, number 7. What is the following compound's systematic name? Now we have 2 groups over here, aldehyde and a ketone. So if you have aldehyde and a ketone, again the aldehyde is more reactive. Aldehyde takes the priority, so we give the number 1 to that. 2, 3, 4. So then the carbonyl group on the 3rd carbon will become a substituent. So the ketone group or a carbonyl group we name as an oxo group. So on the 3rd carbon we have an oxo group, and this is a 4 carbon long chain, so it's a butane, should end in butanal. It's not butanol, so the first one is 3-oxobutanol. Butanol is alcohol, this is a butanal, so then it has to be 3-oxobutanal. Okay, 3-oxobutanol is going to be the name of the compound. And then you are asking to draw 3-bromobutanal. Again, the butanal means there are 3 carbons long, right? So you can draw 1, 2, 3, 4. Butanal means 4 carbons long. I think I said 3. 4 carbons long, right? And then since it's an L, meaning the first carbon should carry your aldehyde functional group. On the third carbon, there is a bromo group. So you will number from 1, 2, 3, 4. Third carbon, there is a bromo group. So you just put bromine right there. So that is 3-bromobutanal. Okay. And then the next one, draw 3,3-dimethyl-4-oxopentanal. Pentanal means there are how many carbons long? 5 carbons long, and it is an aldehyde. So you're going to draw your structure. 1, 2, 3, 4, 5. Okay, so if I put my hydrogen here for the butanal, that's, I can put number 1 there. 1, 2, 3, 4, 5. Okay, now it's good. 5 carbons long. 3, 4, 5. Okay, and then 3,3-dimethyl. So on the third carbon, 3,3-dimethyl means on the third carbon there are 2 methyl groups. So you put 2 methyl groups. And then fourth position, you have an oxo group. So what is oxo group? Oxo group is that you have a double bond, right? So you put double bonded oxygen, carbonyl group. Now we have 3,3-dimethyl 4-oxopentanal. Got it? Easy peasy, right? Good. Next one. What are the products of the following reaction? Now here we have a Grignard reagent, methyl magnesium bromide, and we have a aldehyde and alcohol group. Between aldehyde and alcohol hydrogen of the alcohol group is going to be very acidic. As a result, methyl magnesium bromide Grignard reagent is a strong base. Okay, so that is going to grab that hydrogen of the aldehyde. For example, we have CH3MgBr. So magnesium is delta positive, carbon is delta negative, and then you have a OH group. This hydrogen of the alcohol is more acidic compared to hydrogen of the aldehyde. So what's going to happen is the carbon methyl group is going to, this carbon over here going to take that hydrogen. Okay, so that is going to give you CH4. CH3 going to take that hydrogen, that will make it CH4. Okay, and from the other side it would be magnesium bromide with CH2COH. So you have methane, and then you have COH, and then you have CH2, and then the oxygen going to be with magnesium and bromide. The O minus, then a magnesium is positively charged, so this group over here going to go on next to the oxygen. Okay, so what's going to be the answer? You're going to be making methane CH4 BrMgO CH2COH, so the C going to be the answer. Okay, number 11. Now it is asking, you are given a sequence of reactions, and you need to find out the missing reagents and the structures. So methanol giving you methyl bromide. How would you convert methanol to methyl bromide? Which reagents can we use? We can use any brominating reagent. We can use PBr3 and pyridine. And some of these reactions maybe you have come across in your previous chapters. So organic chemistry is something that you cannot forget what you have learned in the previous chapters. So it repeats. So most of these reactions. So you can kind of remember what you have learned earlier. Okay. So we have CH3OH. CH3OH. We can convert using PBr3 in pyridine. Pyridine is a solvent. Pyridine. It's going to convert to methyl bromide, brominating agent. Okay, and then you have to add something to get something, and then you have adding another 1 and 2 things to make CH3CH2OH. Now let's see how do we know what we need to add. Now let's look at here. Methyl bromide is going to give you CH3CH2OH. Now this is what you can consider. So this methyl group in the end product should have come from this methyl group. And then we have additionally added 1 carbon, okay, and then 2 hydrogens and a OH, okay, CH3. So this is the final product. So this had come from the methyl bromide. Now the other part, CH2OH. Now we have to add 1 and 2 things. What could have been reacting with methyl bromide? So you can consider from the information that we know of, you can add a methyl group to an aldehyde or a ketone. Okay, so when you add, it will become alcohol, right? So this methyl group is added from the Grignard reagent. We can make a Grignard reagent. We can add a Grignard reagent to a carbonyl group. For example, if you have a carbonyl group like that, hydrogen, hydrogen. So these 2 hydrogens coming from the compound that the Grignard reagent has been added. So those are the 2 hydrogens. Remember? And if you add alkyl group to a carbonyl group, this oxygen will become OH, and the alkyl group is going to add on to this carbon. Okay, we have learned this in the lecture, so you can visualize this must have been going on in this reaction. Okay, so when you try to put these things together, we can see so you have a methyl bromide CH3Br after you do the bromination, and then the one is going to be, you have to first make the Grignard reagent. How do you make the Grignard reagent? You add magnesium, and then our solvent is ether, magnesium and ether. So magnesium and ether will give you this Grignard reagent, methyl magnesium bromide. That's going to be number 1. Once you make the methyl magnesium bromide, it is going to react with the formaldehyde, which is CH3MgBr going to react with, so this is going to be number 2 reagent, HCOH. How is it going to react? The methyl group over here, this carbon going to attack this carbonyl group, carbon oxygen bond opens up, and that's going to give you hydrogen, hydrogen. This would eventually become OH. when you add H3O plus. Okay. So for the methyl magnesium, methyl bromide, so this part over here going to be magnesium ether. And then this is going to be number 1 reagent, formaldehyde, and then the second step is adding H3O plus. It will become, so here's the methyl group we add from the Grignard reagent, and then the O minus will become OH, which is CH3CH2OH, that is the product. Okay, I hope you got it. Okay, so the next one, choose the one alternative that best complete. Okay, so what is the product of the following reaction? So here we have a Grignard reagent reacting with carbon dioxide. So let's see how that is going to happen. So you have CH3, CH2, MgCl. Carbon dioxide is this, carbon dioxide. Okay, so magnesium is delta positive. This carbon goes and attack to this carbon, and then the carbon oxygen bond opens up. So you're going to be making carbon O minus, then you have a carbonyl group, and from the other side you have CH2, CH3. And then when you add, second step, adding hydronium ions, which is your acid, that will make it a carboxylic acid, CH3, CH2, COOH. I just change the position or the direction how it is. So the carbonyl group, so this is how normally we write a carboxylic acid. So this is what we're going to be making. So what's going to be the correct answer now? Let's look at, yeah, E, CH3CH2COOH. So it's going to be this one over here. Okay, I have not chosen the same questions I gave you for the homework for chapter 16. So but refer to those examples that I have given you in the homework from chapter 16. Okay. Okay, the next one. Write the word or phrase. Okay, wonderful. What are the products of the following reaction? Again, now here you have an ester with a Grignard reagent. So ester, if you have an ester, remember you can have aldehyde, you can have ketone. Aldehyde, for the aldehyde and ketone, Grignard reagent add only one time. Alkyl group of the Grignard reagent adds only one time and then make an alcohol. But if you have an ester or if you have an acid chloride, the Grignard reagent alkyl group adds 2 times to the carbonyl group and then make the alcohol. Okay, so that's why you have 2 here, 2 methyl magnesium chloride. So let's see how this is going to happen. Now the product of this going to be, if you follow the pattern or if you try to remember the pattern, CH3CH2, so this is the carbon, and then you have this carbonyl group is going to become an OH group. Okay, since this is an ester, methyl group adds 2 times to the carbonyl carbon. So your final product is going to be CH3, CH3. This is the product. Okay, but how is it going to happen? So let's look at the mechanism in a little, maybe in little detail. Though we have seen it in our lecture slides, I will remind you how to do how does the addition happens. Okay, now we have this group CH3, CH2, COOET. Okay, so the methyl magnesium bromide. Methyl group is the carbon ion. This is delta positive, this is delta negative. This carbon goes and attack this carbon. Okay, and then the carbon oxygen bond opens up. Now the product that you are going to form, so you have a ethyl group from here, and then the oxygen will become O minus, and then from the other side also you have OET, and this is the newly attached carbon. Okay, now you have a methyl group. Now first methyl group has attached to the carbonyl carbon, and then the next step is, so you have a good leaving group, which is the ethoxide. So a pi bond forms back and it loses this ethyl group. Okay, so you're going to be forming this molecule, carbonyl group and a methyl group. Now this is similar to a ketone. Now we have two equivalents of methyl magnesium chloride. One methyl group already been added. Now the next, you know, the aldehyde and ketone react with Grignard reagent. Now this ketone is going to again react with the ketone we just made. Methyl magnesium chloride. The second equivalent, so this is positive. This goes and attack to this carbon, opens up the pi bond. So you have two methyl groups attached, and then you have O minus here, and then in the second step when you add hydronium ion H3O plus in the second step, it gives you the alcohol OH methyl group. So always if you have an ester Grignard reagent, the alkyl group adds 2 times and then make the alcohol. Okay, that's how the mechanism works. And then the same thing with the acid chloride. So here's acid chloride. So the chloride group act just as the ester group. So the methyl group over here adds 2 times to the carbonyl carbon. Exactly the same mechanism I just showed you in the question number 13. So the product of this is going to be CH3, CH2, C, this ketone acyl chloride carbonyl group become OH, and then you are adding 2 methyl groups onto the carbon. Okay, same way. So the first time it adds to the carbonyl carbon oxygen bond forms single bond, pi bond leaves, and then chloride leaves. You have a ketone, and then the second equivalent of the Grignard reagent adds on to the carbonyl carbon. Okay. So the correct answer for this one going to be, it's B, right? So there are 2 methyl groups. These are the 2 methyl groups added. This is the ethyl group that we originally had, and then ketone became, the acyl chloride carbonyl group became alcohol group. And number 15, what is the product of the following reaction? Now in this case, we have acetylide anion. Now that's a nucleophile that also going to adds on to the carbonyl carbon, right? So this group over here, this group goes and attack to this carbon. This bonds opens up. So you're going to have your CH3, CH2, H, O minus. And then from the other side, I'm going to draw it over here. You have the carbon that's added, a triply bonded, and then the carbon, CH2, CH3. Okay. And then in the second step, when you add H3O plus, what H plus is same as hydronium ion. Okay. So then this oxygen O minus grab a proton and complete the process. So we have CH3, CH2, and then you have your OH group, hydrogen, and then the carbon, triply bonded carbon, CH2, CH3. Similar to the Grignard reagent, only the difference is here the nucleophile is acetylide anion. Okay. And then the next one, number 16, draw the product of the following reaction. So you are adding sodium cyanide and hydrochloric acid, and in the second step you are adding hydrochloric acid, water and heat. Now cyanide, sodium cyanide, cyanide here is the nucleophile. So the first step going to be in sodium cyanide, cyanide going to act as a nucleophile and attack the carbonyl carbon. Carbon oxygen bonds opens up. So you're going to have O C N, and it would be O minus, but since we have hydrochloric acid, it will protonate to make it a cyanohydrin, and the name of this one is cyanohydrin, and we came across this in lecture, cyanohydrin. And then this cyanohydrin can undergo several reactions. If you add acid and water and heat, so this carbon nitrogen triple bond hydrolyzes to give you a carboxylic acid. That is what happening over here. So when you add the second step reagent, so this cyano group gonna get hydrolyzed to give you a carboxylic acid, OH alpha hydroxy carboxylic acid, and you have this exact example in our lecture slides. Okay. And number 17, draw the product of the following reaction. So you have a ketone and you have a sodium borohydride. Sodium borohydride is a reducing agent. Reducing agent means adding hydrogen. So H minus is going to be the reducing agent. In sodium borohydride, H minus act as the nucleophile, goes to this carbonyl carbon, okay, and then this opens up and it's going to give you an alcohol. That's easy to remember. OH, it would be O minus, and then when you add water it's going to pick up a hydrogen alcohol. So with sodium borohydride, ketones and aldehydes can reduce to alcohols. Okay. What is the product of the following reaction? Again, it's easy. And you are adding a hydride H minus. So the ketone we have here, ketone will become an alcohol. So then it's going to be this answer. Ketone become alcohol with the sodium borohydride reducing agent. Okay, and then the next one, what reagents should be used to carry out the following synthesis? Now we have given several reagents. So which one are we supposed to carry out? Which one are we supposed to use to carry out this reaction? Hydrogen, palladium, carbon. What happens if you add hydrogen, palladium, carbon? If you have alkene, that is a hydrogenation reaction, hydrogen, palladium, carbon, right? So this one we use for the hydrogenation, meaning this one would reduce a carbon-carbon double bond to an alkane. This will completely hydrogenate the double bond and will give you alkane. So we cannot use that because we want to retain this alkene. We should not do anything to that. And then the BH3 followed by water, a hydroboration. BH3 followed by water is a hydroboration reaction. Do you remember from organic 1? Hydroboration reaction is adding alcohol group or a water molecule across a double bond. Okay, so we cannot use that either. So then the alkene will become an alcohol. We want to keep the alkene as it is. And then the hydrogen and the platinum catalyst, another hydrogenation reaction which will make alkene become alkane. So you cannot use that either because we need to keep the double bond. And then only thing that we need to reduce is the carbonyl group we need to convert to alcohol. So sodium borohydride followed by water. Yes, that is it. So sodium borohydride only will reduce a carbonyl group to alcohol. It will not reduce alkene. So the correct answer is D. Okay. What class of organic compound is formed when cyclopentanone react with ethylamine? Cyclopentanone is this molecule, cyclopentanone with ethylamine. Ethylamine is CH3, CH2, NH2. Okay, now what is this? Is a primary amine or a secondary amine? It's a primary amine. So primary amines with carbonyl compounds forms imine, and secondary amines with carbonyl compounds form enamine. So this is imine. Okay, so the class of compounds is going to be imine because its ethylamine is a primary amine. Okay, and then the next, draw the product of the following reaction. Now here we have a carbonyl compound with a secondary amine. So with the secondary amines, it's going to form enamine. Okay, so meaning, so this instead of the carbonyl group, it's gonna attach to this nitrogen. Okay, so you can remember so the first compound it is going to form, if it is a primary amine, you're going to be forming a double bond right there. Double bond, and then we have this. Okay, now see, the nitrogen has 4 bonds. So because of that, nitrogen will have a formal charge of +1. Normally the compounds are stable when they don't have any charges on it. So to get rid of the charge of the nitrogen, instead of having a double bond between the nitrogen and the carbon, so you will recall from your mechanism, this hydrogen is going to lose and then forms this molecule where you're going to have the double bond between the carbon, and then this one is going to be neutral nitrogen without any charge on it. So since this has an ene and imine, this is an enamine. Enamine is being formed between a carbonyl carbon and a secondary amine. Okay, enamine. So we did this mechanism in our lectures. I hope you guys remember the mechanism. Or do you want me to show the mechanism? It's in the lecture slides. You don't have to show the mechanism, but this is the product, right? Remember that secondary amines with carbonyl compounds form ene and imine. Enamine, the double bond is going to be formed in the molecule that had the carbonyl group. Okay, so that's the enamine. And then the next one, draw the product of the following reaction. Now here we have 3 pentanone with ethylamine. Now ethylamine is a primary amine group. So primary amine group, you are forming imine, not enamine, imine. So you can form the double bond between the nitrogen and carbon. So see, this is a carbonyl group, and then this is a primary amine going to form a double bond with the nitrogen. Okay, so it's going to be like that. The double bond going to stay there. The nitrogen is going to form between nitrogen and carbon forms the double bond, and then the ethyl group CH2, CH3 that we had on the nitrogen going to stay like that. So that is a imine with the primary amine. So this is imine. Okay. That is the structure for the molecule. And then draw the product of the following reaction. So with methylamine, and then you are doing a reduction. So now we need to know, so there are two-step reaction. What's going to happen in the first reaction? Okay, now again the same thing, just like we had seen in the previous reaction. Here we have a primary amine, methylamine, and a carbonyl compound. It's going to form imine, primary amine. So your imine is going to be CH2CH3, and then you have a carbon, hydrogen, going to form the double bond with the nitrogen and a methyl group like this. So with the first reagent, methylamine and the trace acid, you're going to form this. Okay, and then the sodium cyanoborohydride. This is a reducing agent similar to sodium borohydride. This is a reducing agent, but it is milder than sodium borohydride because one of the hydrogen is replaced by the cyano group. So what's going to happen is it's going to reduce the double bond between the carbon and nitrogen. Okay, this bond is going to reduce, meaning hydrogen going to be on that carbon and the nitrogen. Okay, so then your structure would be with the sodium cyanoborohydride. You have CH3, you have CH2, and then this carbon over here is going to be CH2, and then you have your nitrogen, and that nitrogen right now has only one methyl group, so but it's going to be hydrated, not hydrated. Hydrated means adding a water molecule. That's not the correct one. Hydrogenated. Okay, add a hydrogen, and then you have a methyl group. So basically you add hydrogen over here and here by adding sodium cyanoborohydride, CH3 CH2 CH2 NH CH3, which is going to be B, right? Correct answer is going to be B. Next one, what are the products of the following acid catalyzed hydrolysis reaction? Now this is the reverse of enamine formation. Do you understand? Do you recognize this is an enamine because we have a ene group. We have an ene group and you have an amine group. So this is an enamine. How does the enamine form? Between a carbonyl compound and a secondary amine. So what we're going to do is you're going to break the bond between carbon and nitrogen. You're going to break this bond right there over here. So then, and we're going to add a water molecule. And then we have seen the mechanism in the lecture slides. So this would become a carbonyl group, and from the other side it would become the secondary amine, which is this. So this is what you're going to be getting when this is being hydrolyzed. And you will end up having another hydrogen, making this a positively charged, that will make it not reversible. That's what we learned in the lecture. Okay, even though it is showing here the two-sided arrows like the equilibrium, but once it hydrolyzes, it cannot go back because the amine is already protonated. Amine needed to be deprotonated to make it a nucleophile. Okay, so these are the products of the hydrolysis. And number 25. What is the product of the following reaction? Please learn the mechanism for this reaction. It's on the lecture slides. So here you have aldehyde and then you are adding 2 molecules of methanol in the presence of acid. So what are we going to form in this reaction? What is the name of these categories? These are acetal and hemiacetal formation reactions, right? Let me refer to the mechanism so I can draw it here. Okay. Okay. So the product is going to be formation of acetal. So how do you make the acetal? So CH3, CH2, carbon, hydrogen. So for this one, the final product would be a methoxy group. So from the methanol, methoxy groups, two methoxy groups are going to add on to this carbonyl carbon. So the product is going to be OCH3, OCH3. This one. But let's see what is the mechanism, how it is going to form. So since it's going to happen in the acidic medium, the first step is always the protonation. Okay, so we have CH3, CH2, COH, hydronium ion, HOH. So this is positively charged. Oxygen has a lone pair. This is going to go and grab a hydrogen. And then the first step is the protonation. CH3, CH2, OH, H. This would become then positively charged. When this is positively charged, a methanol going to go and attack the carbonyl carbon, CH3OH, methanol. Okay, and this is going to give you the structure, 1, 2 carbons, and then you have hydrogen, OH, and then you have O, CH3, and hydrogen, and this is positively charged. The methanol is added on to the carbonyl carbon, and then another water molecule comes and grab this hydrogen and give you this structure, hydrogen, OH, O, CH3. Now once this is being formed, this alcohol OH is going to protonate again. It's going to grab a hydrogen ion from the hydronium ion. This is going to grab this hydrogen. It's going to form this molecule, will become a protonated alcohol, this group, and then oxygen will be positively charged. Then what happened? Then there is a good leaving group. So this oxygen forms a pi bond and then the water molecule leaves. Okay, so water is eliminated. Do I have space? Yes, I do. Okay, good. It's going to form this structure, hydrogen, double bond, oxygen, and then this would become now positively charged. Okay, and then what happened? Another water molecule is another methanol molecule, OCH3, CH3OH. I was trying to see if I'm doing too many steps. No, I'm in the right path. So goes here and attack, and then make this molecule OCH3, OCH3, and a hydrogen with a positive charge. And then another water molecule comes and take this hydrogen and forms the acetal. Hydrogen, OCH3, OCH3. Okay, so that is how the acetal is being formed. And this one is, this mechanism for the acetal formation you can find in the lecture slide 67, chapter 16, slide 67. Okay, so you can refer to that. That's what I drawn over here. All right, the next one. Which of the following reagents should be used to form 4-octene? So 4-octene. What is 4-octene? How do you draw it? Let's see. 4-octene octene means how many carbons? 8 carbons, right? 2, 3, 4, 5, 6, 7, 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 4-octene would be this one. There is a double bond. Oh, look at that double bond. It's not a pretty one. Okay, 4-octene. So which one can we use to make this 4-octene? Now we are given some reagents, 4-bromo-octane and a tertiary alkoxide, 4-bromo-octane and sodium methoxide, and then we are given a Wittig reagent conditions. Okay, cool. And then C and D, they are Wittig reaction conditions. So remember the Wittig, that you can form an alkene with a carbonyl compound and an alkyl halide. So we can break the bond between these two carbons to find out what are the Wittig reagents that we can use. If you break it, so from one side we have 1, 2, 3, 4, and for the other side also we have 1, 2, 3, 4. So if you put alkene into one side, it would be 1, 2, 3, 2, 3, 4 carbonyl group, and a hydrogen can be one of the components, and from the other side there are 4 carbons needed to be. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then you can have 1, 2, 3, 4, and then the phosphorus yield PPH3, phosphine group. Wittig reagent conditions. This F, it's a P. So the one of the reagents is this group, butyraldehyde or butanal, 1, 2, 3, 4, and from the other side your Wittig phosphine yield need to be with 4 carbon long, 1, 2, 3, 4, and the double bond to the phosphorus with PH3, C6H5 benzene rings. So looks like D is the correct one. So for D we have 1, 2, 3, 4 carbon, 1, 2, 3, 4 with the PPH3, and then from the other side 1, 2, 3, 4 with 1, 2, 3, 4 and aldehyde. So this is a Wittig reaction. Okay. Number 26. And then the next one, draw the product of the following reaction. Draw both stereoisomers. Okay, wonderful. So this is also a Wittig reaction condition. So in a Wittig, what we're going to do is, you see this carbonyl oxygen will be lost. Oxygen will be lost. You can keep the double bond. And from the other side, the phosphine yield, this side is going to attach to the carbonyl group. So basically, it's going to be something like that. You have this part, carbon, if I draw my CH3 there, and then the double bond, and then you have the carbon, hydrogen, CH3. That's one. Okay, both a stereoisomer. So that's one stereoisomer, and then the other one could be like this, CH3 hydrogen, cis and trans, these two. Okay, and then the 28, similar, draw the product of the following reaction. Again, the same concept. So your carbon oxygen bond is going to break from here, this is going to break here, going to keep the double bond, and then you add the this part, you add this part to this part, easy. So CH3, CH2, CH, put the double bond, carbon, CH3, CH3, that's it. Okay, that's the main product. It's asking to the products. So then the other part would be phosphorus is going to form a phosphonium, phosphine oxide, that with the two phenyl groups, pH is the three phenyl groups. And then the 29, what is the product of the following reaction? Learn the mechanism for this reaction. It's on the lecture slides. Same thing that we did earlier. Now we are adding water. Earlier we added methanol. Okay, so it's going to form an acetal. It's going to form not acetal, it's going to form a hydrate. So CH3, CH2, CH, and this would be OH, and this would be OH. I think this is a gem diol. That's what it's going to form. Okay, same mechanism like the previous one. So CH3, CH2, H. First step is oxygen, grab a proton, will become OH plus, and then the water molecule goes and attack the carbonyl carbon and forms this intermediate CH3, CH2, OH, H, O, H, H. This makes this oxygen +1. So another water molecule goes and grab this hydrogen and forms this one, H, OH, OH. Okay, that's easy. Okay. Okay, and then the next one, draw the product of the following reaction. Again, this is a formation of an imine. We came across this one before. This is a primary amine. This group is a primary amine going to react with this one to form an imine. Carbon, hydrogen, ethyl group, nitrogen, have another nitrogen, it has a hydrogen on it, and then you're gonna draw the rest. NO2, NO2. Like this. So that is the product for that one. Okay. I want to check something. Okay, I think that's it. I hope you understood. Let me know if you have any questions. Okay, then bye for now.